Now we are going to look at the examples 2, where we have alpha, beta, k for the previous year, and c and sigma k. We want to calculate the mean and the standard deviations, and calculate the median and the 5% quantile of M70 2018. And for part B, we are going to calculate the P70 2018, assuming the central draft takes the means value from alpha and assuming there is a constant force of mortality in between the integers. And we want to explain why this is not the mean value of P70 and 2018. As for question 2, for part B, you want to find the 50 percentiles and 95 quantiles of P70 2018, assuming constant force of mortality in between integers. As for part C, it will be for the same thing in part B, just that you want to find it using UDD approach instead of the constant force of mortality. So for here, we know that LM70 2018, this one we can get from the Lickwater equations for A70 plus beta 70, alpha 70 plus beta 70 K 2018, where K 2018 can be replaced with K 2017 plus C plus with sigma k zt, where zt is normal 0, 1. For here, you can see that replace all of the numbers that we know for alpha, beta, k, and c and sigma, and we are going to get negative 2.684 plus with 0.04, negative 10 minus 0.4 plus 0.7 zt. So this one would be equals to negative 3.1 plus 0.028 zt. For here, since zt is normal 0, 1, we can say that LM70 2018, this one is also normal with mu as in negative 3.1 and sigma as 0.028. So if we have the random variable here with value, let's assume that mu is equals to negative 3.1 and sigma is 0.028. For any x with normally distributed mu and sigma here, any exponential of x is the log normal distributions. So if y is exponentials of x, so y is log normal with mu and sigma as the standard deviation, and the expected value of y is the expected value for log normal would be e mu plus sigma square over 2, and variance of y would be equals to e 2 mu plus sigma square e sigma square minus 1. And we want to find the expected value of m and also the variance of m. So for our case, we know that M70 2018 is E LM70 2018. If this one is normally distributed with negative 3.1 and 0.028 for sigma, so for here it will be log normal. So the expected value of this side is the expected value of the log normal, which is, we can replace it with this one. We are going to get EM70 2018 here is equals to e to the power of mu is negative 3.1 plus 0.028 square over 2, where you are going to get equals to 0.04507, and the variance for M70 2018 here, you are going to get equals to, just replace it inside this variance formula for the log normal, and you are going to get equals to 0.0013 square. The next thing is you want to find the median. Median is the 50th percentile. So let's denote that Qx is the quantile. So if we are looking for Q 50% of LM70 2018 here, this is equals to negative 3.1. From the expected value here, we can see that the average is the negative 3.1. So this is the 50th percentile, because we know that Q 50%, the value for this one is equals to 0. Under the normal distributions, here mu equals to 0, this one would be the 50th percentile, or the 50%. Okay, for here we are going to get Q 50% of M70 2018, which would be equals to E negative 3.1, which is 0.04505. The next thing that we want to find is Q 5%. For 5%, if you look at the normal table here, the normal graph here, 5% will be somewhere around here. If you check the normal table, you are going to get this is equals to negative 1.645. Thus Q 5% of LM70 2018, this is equals to negative 3.1 plus 0.028 times with negative 1.645, which is equals to negative 3.146. This one is simply use Z is equals to Z alpha equals to X minus mu over sigma. So since I want to find X, we just rearrange this and we got this. Okay, here Q 5% is E negative 3.146, which is equals to 0.04302. That's it for part A. Now let's look at the questions for part B. For part B, we want to find the central depth rate's mean value from, we want to find the P70 2018, assuming that the central depth rate takes the mean value from A, which we got it just now, and assuming that the constant force of mortality in between the integers, and we want to explain why it is not the mean value of P70 2018. When we are using the central depth rates equals to the constant force, for here we are going to get M70 equals to e negative 3.1 plus 0.028 square over 2, where from here my P70 will be equals to e to the power of negative m, I'll just put bracket, negative m 70. So for here, just use the calculator, then I'll get this one equals to 0.9559336. This is not the same as the expected value of P70 2018. For P70 2018, here I forgot to put 2018, I'll just put 2018 here. Okay, for P70 2018, this one actually we can get it from expected value of the M70 2018, where this M70 2018 is e negative e to the power of negative 3.1 plus 0.028 zt. This expected value is quite complicated, so you need a programmable calculator or computer to solve this. This one shall be equal to 0.9559338, which is roughly not the same as this one. The way the calculation is also a bit different, okay, but it is almost the same. It's just estimated. So for the next part, where we want to find the Q50%, the 50th percentile, Q50% of P70 2018 here, we are going to get equals to e negative Q50% of M70 2018, which is also equals to e to the power of negative 3.1. And as for the next one, e to the power of negative e negative 3.1. As for the next one, where we want to find the Q95% of P70 2018, this one is equals to e to the power of negative Q 5% of M70 2018, which is equals to e to the power of negative 3 e negative 3.146, as what we found in part A. Here would be equals to 0.95789. I'll let you try question C by yourself, and the answer for question C, we will discuss this in the class. Thank you.